everyone.
Hello. Welcome, everyone. How are we doing?
Welcome, welcome.
Thank you. All right. Welcome to Advanced VPC Design and What's New in Amazon VPC. I think this will be the 7th year this session's been running now.
Yeah.
So thanks, everyone. We really appreciate you all coming along. The idea of this session is really to talk about advanced VPC architectures, of which we have a lot, and then also talk about what's new over the last 12 months. So we have a lot of slides, a lot of content. Don't worry if you miss a photo here and there because it's tempting to take a photo of some of the slides. We've actually got a QR code at the very end of the session which takes you to an abridged version that has all of the goodies from the content that we have here. So you can access that immediately. That was one of the biggest pieces of feedback I think we've heard.
Yeah, absolutely.
Okay, so well, intros. I'm Matt Lewis. I'm a senior principal in the EC2 networking team. And Alex?
I'm Alex Swedish. I'm a networking specialist, solutions architect within strategic accounts.
And I guess we love AWS networking. It's why we're here.
For sure, for
all
sure.
Right, let's get rolling.
Let's get
Cool.
rolling.
Okay, so the prologue. This is a 300 level session, but we always like to start at 100 level and build our way up. I'll do this super, super fast. It's almost kind of a meme at this point of how fast that we kind of roll through some of this stuff here. But starting with AWS infrastructure and how it's deployed around the globe. So we actually have 34 regions now, 41 local zones, 141 direct connect POPs. When I started, I think we had 16 back in 2013 or something. And we have 6 million miles of fiber now. So we've got a massive, massive backbone from a networking perspective, interconnecting all the good stuff that we have in our AWS regions. Speaking of regions, if we zoom into our US West 2 or PDX region, regions are made up of data centers, and you folks all know this stuff. Some of you might be new here. And we group these data centers together into availability zones. So they're basically fault-tolerant groups of data centers, which are all interconnected. We'll come back to that. But an Amazon VPC is a region-level construct that spans all of those data centers in that geographic region, which allows you to deploy EC2. And EC2 is actually on a rack in a data center. And so it lives right there, probably, maybe. Who knows? But it's on a physical piece of metal. Now, that EC2 instance, as you see it from someone who's interacting with VPC inside the console, it's an EC2 instance inside a subnet. And if we kind of zoom through this, you might be talking to the public internet through an internet gateway or an egress-only internet gateway if you're using IPv6. You might have private subnets. You might have a security subnet or a NAT gateway subnet, which does NATing, and we have our AWS network firewall in that subnet potentially. And you might have an elastic load balancer giving you auto-scaling inside that VPC, which is really unlocking the power of cloud. We also have services that are public outside of the VPC, and so you'll see a lot of interconnectivity between these services, like S3, which was actually made before Amazon VPC. We'll talk about getting to those services privately. Customers also have more than one VPC, so you can connect to those with peering. Alex is going to cover some stuff around peering. You can do cross-region peering. We also have Transit Gateway 2018.
Yeah, 2018.
2018, we released Transit Gateway. You can connect up to 5,000 VPCs. Customers have really taken advantage of that, and we've seen customers deploying thousands of VPCs in their environment. Transit Gateways are a region-level construct, so you can connect to other regions. We also have Cloud WAN, which is a newer addition to our service. Oh, we have TGW Connect. Almost missed that if you're connecting on premises via SD-WAN headends. And we have, Cloud WAN's coming up later. We have a hybrid connectivity via Direct Connect to your on-premises. You can use VPN connections, and you can do Direct Connect via Direct Connect POP. And here we have Cloud WAN. So Cloud WAN is basically a global service that spans all regions, almost all regions.
Yeah.
Alex will dig into some really cool advanced architectures with that one, so connecting VPCs. And you can also use Cloud WAN Connect as well. And then we have Private Link, which I think was a 2016 or 17 service.
I think so, yeah.
Maybe. So that's been around a little while. But privately connecting to services inside your VPC was one of the biggest asks at the time. And so you can connect to public services using AWS Private Link or interface endpoints, or you can build your own custom services as well. We have Gateway Load Balancer if you want to deploy your own scalable fleet of firewalls. Highly recommend checking that one out. We have a new addition, VPC Lattice. We've got a lot of advanced architectures on VPC Lattice here today, so we'll be digging into that one. We have Ava, which launched 2 years ago in preview, I think it was. This is our zero trust service, allowing you to connect into the VPC, VPN-less type connectivity. We've got some new launches for that one. And finally, as it stands, in December 2023, this is what your architecture could look like. These are all the components. Okay, so that leads us to, 2024.
Yep, 2024.
Alex, take it away.
Thank you. So yeah, in 2024, we released a lot of features, as you all may know from all the announcements in the past year. We'll start this journey by going through the foundations and all the way to advanced architectures. And the foundations mean or start with IP address management. On AWS, we have Amazon VPC IPAM, which is the IP address management service that allows you to streamline your IP addressing both in IPv4 and in IPv6 across multiple regions and across multiple accounts. Now, IPAM in 2024 had a bunch of features that were launched. Bring your own IPs registered with any internet registry are now supported. Amazon Contiguous provided IPv4 blocks, which allow you to essentially use Amazon-provided IP addresses across multiple accounts within a region. And bring your own IP and bring your own ASN across AWS local zones, another very important feature asked for customers who are deploying their compute towards the edge. Now, the newest feature launch that we are going to be talking a bit about is OU level filtering in IPAM. We have heard from customers their need to minimize the scope of management in IPAM, to exclude certain environments in their AWS organization, and that is what OU level filtering helps you achieve. Now, it wouldn't be talking about IP address management if we would not be talking about IPv6. And IPv6 on AWS, you folks probably know, it is something that we are striving to support across all our services. In 2024, we had 20 plus IPv6 support announcements, which is amazing. I am personally extremely excited about this. We've launched Amazon VPC private IPv6 addressing, and we're going to be talking a bit about that in a second, and EC2 Instance Connect IPv6 support. This is one of my personal favorite features. The reason for it is because you don't need public IPv4 instances, IP addresses, to SSH into your instances anymore. So if you support IPv6, you can use EC2 Instance Connect, and you can log into your instances without public IPv4 addresses. Really important. Now, we talked about private IPv6 addressing, and perhaps some of you are wondering, well, where is this coming from? Isn't IPv6 supposed to be public? What's the deal with it? Well, the Amazon VPC supports two types of IPv6 addresses, which are public IPv6 addresses that are not advertised on the internet from AWS, and private IPv6 addresses. The private ones are three types. The first one is bring your own IPv6 GUA, or global unicast addressing, that is not advertised on the internet from AWS. You can choose to do that. And you have full control over the advertisement status. The second type, which is the newly launched one, is support for ULA, unique local addressing. Keep in mind that ULA is not and can never be advertised on the internet. That is the protocol definition. So if you require internet connectivity, you do need to have a sort of IP addressing translation. And last but not least, private GUA, which may seem like a contradiction in terms, but we are mapping here the construct from IPv4 that our customers are really familiar with, which is the ability of configuring private IPv6 addresses on the VPC that are never advertised on the internet and can never be in the future, but that provide you with the flexibility of using them however you want inside your own VPC. Now, we've talked about IP addressing, and that is the foundation of foundations. But as we go up the stack and we talk about Amazon VPC networking, we have VPC security foundations, and Matt is going to take us through the journey.
All right, cool. So security, you've probably heard this before from someone from AWS, but security in AWS is really job 1, 2, and 3. We focus on security a lot. Any product that we build, we think about security first and foremost. With a VPC, we're always trying to think of ideas that we can build more security into the VPC. But to start with the foundations, you start with network access control lists and security groups. They're your two main instruments of implementing security inside a VPC. And so if we look at what network access control lists and security groups really look like, and you've probably all used these before, the network access control list is basically a stateless rule that you apply to a subnet. A security group is a stateful rule that you apply to an instance, or some other entities, but generally an instance. And so if we have a look here, we can actually reference security groups from one to the other. So you can see here, we're actually referencing the A or B security group for our web apps to say, hey, anything inside that security group, we can allow access to our web apps. And you've probably all got scenarios where you're doing this today. Okay, so again, security groups are a resource level stateful entity, and basically they're defined inside the bounds of a VPC, traditionally. Okay, so if we start talking about new security group features that we've released this year, we now have VPC associations. And so the idea here is you can create a security group within your account, and you can use that security group across multiple VPCs. And so if we have a look at what that looks like, basically you've got two VPCs here, and security groups used to be a VPC level construct. What we've done is said, well, we saw folks configuring the same security group rules across different VPCs, and you would get a new security group ID each time. That's kind of a pain. So here, you can actually reference or associate, not reference, we'll come to referencing later. You can associate security groups with entities in different VPCs. So the security group is really now a account level construct. Okay. And you can only associate non-default security groups to across your VPC as well. All right, we also have security group sharing. So VPC sharing is actually something that a lot of you folks use. I was a little skeptical when we launched VPC sharing. I was like, hey, do we really want to take a VPC and share it with other accounts? Why not just build a new VPC and interconnect them with something like a transit gateway? But I'm actually fully on board with VPC sharing now, have been for many years. It's a very useful tool to say, I'm a VPC owner and I own the VPC and the routing and all the constructs for the VPC. I'd like to share a subnet with another account, and that participant can then spin up things inside that VPC. Let's have a look. I think I've got a slide here for that. And so basically what we've got here is the VPC, and we've got the subnet shared across multiple accounts. So the subnet is actually being shared. With VPC sharing, VPC security group sharing, you can now, sorry, we're going to the next slide, you can now take the security group and share it with the participant in that VPC. So the security group used to be a VPC construct just for the owner, but now it's for the participant as well. So this is another way of making your folks' lives a little bit easier around security groups. And so we've got a couple of considerations here. So participants can continue to use their own security groups if they wanted to, for example, but they can also use the shared ones. I think that's probably the biggest takeaway here. And also, again, you can't use this with the default security groups or default VPCs. Okay. So lastly, and this is hot off the presses. I think this was yesterday, was it?
No, it was, I think, a couple of weeks ago.
Oh, a couple of weeks ago, okay. Well, I started playing around with it yesterday, so there you go. Block public access. So one of the things we've heard from customers is, hey, I've got a VPC, and I can control things through security groups, NACLs, routing, IGWs, elastic IPs, but I just want one blunt lever to say, I don't want any public access for this VPC. And so if we look at what a VPC looks like, you can see the different components here. You've got a public subnet, it's got an IPv4 or v6 address. You've got a private subnet that might be talking via egress-only internet gateway for v6 or a NAT gateway for v4. And so you basically need to control all of these different components to say, hey, I'd like to block access for these particular subnets or not, and you control that policy. And so the internet gateway here is allowing bidirectional traffic. The egress-only internet gateway is only one direction. But if we have a look at block public access, basically what we're doing now is saying, hey, I want to turn off all public access for this VPC. And so there's a one-click declarative control for the VPC. You can also add subnet level exclusions if you wanted to, which is also useful. Let's take a quick look at what it looks like. So you actually have two modes here. You can do bidirectional or ingress-only mode, which is useful. You can use Network Access Analyzer to assess the impact of blocking access for resources as well, which is definitely useful. I feel like Network Access Analyzer is one of those services that isn't used enough for folks, for compliance folks definitely, but for the average Joe like myself, I'm not diving into that quite as much as I probably should. And you get flow level visibility for packets that are dropped as a result of configuring block public access as well. Okay, now we get into the connectivity of VPCs for those folks that have thousands of VPCs. Alex, take it away.
Thank you. So yeah, VPC connectivity. We're talking about VPC connectivity because the default, I would say, to begin with, architecture on AWS is no longer a single VPC and a single account. Multi-account, multi-VPC architectures are a standard and are aligned with the AWS well-architected framework. So whenever we're talking about multiple VPCs, we're talking about connecting VPCs, right? So the first option for connecting VPCs is Amazon VPC peering. VPC peering is a distributed connectivity model for VPCs. It's a point-to-point connectivity model, and it's non-transitive. So keep that in mind as we go through all the other connectivity options. You can peer together a limited number of VPCs, and the benefits of VPC peering are the fact that you don't have any latency added by VPC peering, and the throughput limitations are only imposed by the available instance bandwidth. So let's see how that works. As a foundational VPC connectivity option, when you pair two VPCs together, you have the flexibility of adding the routes in the route tables for each of the VPCs. Now, a couple of callouts here that we've talked about. Keep in mind that peering is not transitive. You can use security group referencing with VPC peering inside the same region. And we are going to come back to this one in a couple of slides. Also, keep in mind the fact that network address usage or the number of resources that you have in VPCs, those mappings add up when you have VPC peering within the same region. Now, we want to scale though, right? And as we scale our multi-VPC, multi-account architectures, VPC connectivity across hundreds or thousands of VPCs is something that becomes the norm, right? So here's where AWS Transit Gateway comes into the picture. Many of you may be already familiar with it. It was launched actually at my first reInvent. I was a customer back then. So if we talk about Transit Gateway, we talk about a hub and spoke type connectivity model, right? Where the hub is the Transit Gateway that connects thousands of VPCs together, provides hybrid connectivity, all localized within the same region, right? And brings up the simplified operations and management. Now, if you look at how Transit Gateway works, it's really simple, really straightforward. You attach VPCs, you attach resources to it, and then you can configure multiple route tables, and you can associate and propagate those attachments to those route tables. Very important here. I've seen this a lot with the customers that I'm talking to. There's a very big difference between association and propagation. When you associate an attachment to a route table, the traffic that comes in to that route table from that attachment is the one that is subject to the routing rules in that route table. Whereas you can propagate an attachment to many route tables on the Transit Gateway, and you can therefore get those routes automatically populated in those route tables. Now, probably the second thing that is very common is for customers who start with VPC peering, right? Who start with a smaller number of VPCs and they grow and they implement multiple multi-account architectures, is, well, I have VPC peering. How do I get to Transit Gateway? Do these two things work together? And the answer is yes, because VPC peering is a point-to-point connectivity option, right? Is a very specific routing option. Whereas Transit Gateway is a routing hub, right? So you can configure less specific routing options there. You can see here in this example that we've configured a summary route through the Transit Gateway and a very specific point-to-point route through the VPC peering. Now, I mentioned we're going to come back to security group referencing, right? Matt talked about 2 security group features that we launched, security group VPC associations and sharing of security groups with participant accounts in the same shared VPC. But one of the main features in security groups was before those 2, security group referencing within a VPC and between VPCs that are paired in the same region. And now we support security group referencing across Transit Gateway. This has been a feature ask since the beginning of Transit Gateway, and it was probably one of the biggest feature asks for Transit Gateway. Now, what you can do with this feature is now use your security group referencing configurations together with Transit Gateway and keep that resource identity, that is the security group, when connectivity goes through the Transit Gateway. Now, how this works, very important. You configure security group referencing exactly as you used to do it within a VPC or across VPC peering using the security group ID. However, on Transit Gateway, only inbound rules are allowed, and you do need to enable security group referencing on the Transit Gateway as a whole, and then on the specific attachments that you want security group referencing to work. Very, very important. And the last call out there is probably the question that has come up most often. Can I use security group sharing and security group referencing and security group VPC associations? And the answer is absolutely yes. It depends very much on your use case, where you would use each feature, right? But you can absolutely do that. And now, Transit Gateway, routing hub within a region. We talked about kind of the evolution of network architectures on AWS. We talked about a VPC, an account, multi-VPC, multi-account, peering, Transit Gateway. And now we're talking about actual next level of architectures on AWS, which is multi-region connectivity, right? Application requirements drive multi-region deployments for whatever reasons, either client location or resiliency requirements, or depending on each service requirements. Now, how do we get to global connectivity, and how do we get to this simplified model where we don't have to necessarily peer Transit Gateways together and manage those peering connections? And here is where AWS Cloud WAN comes into the picture. It's been a service that has been around for quite some time and has caught up on features in the past few years. And we're going to talk about a few of them today. AWS Cloud WAN allows you to express your network intent. Amongst network engineers and network folks, network intent is a word or 2 words that mean a lot when we're talking about the network connectivity. And AWS Cloud WAN allows you to do that through its policy. It gives you unified traffic segmentation and holistic monitoring. Now, with Cloud WAN, we have a couple of components that we need to recap before we dive into the new features. We have core network edge, policy, segment, and attachment. Let's see each and every one of these. So the first one is the core network. It's the global construct that AWS manages and spans the regions where you define that core network to exist in the network policy. In each region, Cloud WAN maintains a core network edge, which is the routing hub in that region. It's the place where all the attachments are associated. Now, all of this is not configured as you would configure Transit Gateways, right? You would go and you create a Transit Gateway object and you would get an ARN, right? Everything is configured through the core network policy. Here's where you define the autonomous system range, number range for your Cloud WAN core network, where every CNE gets its own autonomous system number in BGP. Here's where you would define the edge locations, which is where your Cloud WAN core network lives. And here's where you define, for example, attachment policies. And we're going to see in a second what these attachment policies do, so that you don't have to go and manually configure every single attachment in your environment to a construct like Cloud WAN. Now, once you've configured the policy, you get to express that intent in terms of global segmentation. And global segmentation is a very common type of need for global networks. Then you create attachments, and Cloud WAN supports now actually 5. We're going to start with the ones that are the foundational ones, and we're going to get to the new one in a second. VPC, GRE-based connect attachments, tunnel-less connect, transit gateway route table, and site-to-site VPN. Let's review every single one of them, just to make sure we're all aligned and on the same page. So VPC attachments, once you attach a VPC to the core network, in that VPC, the core network maintains elastic network interfaces, 1 per availability zone. Keep in mind that the VPC CIDRs are automatically propagated in the segment where the attachment policy actually specifies that that attachment needs to be associated. So the CIDRs of the VPC, both in IPv4 and in IPv6, are automatically propagated into the segment. However, you still have control over the VPC route table. So on the VPC side, you get to decide what you want to route to Cloud WAN. Cloud WAN does not automatically inject routes into the VPC route table. Now, GRE Connect. A lot of customers have expressed the need to integrate their SD-WAN appliances or security appliances with Cloud WAN, as well as with Transit Gateway in a simplified manner. And with GRE Connect, there is a transport attachment, which is a VPC attachment, a Connect attachment, and on top of that, the Connect peers that establish BGP sessions with the core network edge. Now, also customers have told us that GRE Connect-based tunnels are limited to 5 gigabits per second. So we listened, and tunnel-less Connect is available on Cloud WAN for native integration of SD-WAN appliances, where because it's tunnel-less and because there's no GRE as a transport tunnel, you get the full instance bandwidth for connectivity to Cloud WAN. So no more throughput limitation. Now, TGW route table attachment. This is an attachment type that is here to simplify migrations and integrations with your existing transit gateway environments. And it requires a transit gateway to core network peering, as well as each route table on the transit gateway to be attached to a core network segment. You can choose which route tables you extend into your core network. The important thing is that there's dynamic routing in both directions. So Transit Gateway automatically advertises to Cloud WAN all routes in the Transit Gateway route table. Cloud WAN automatically advertises to Transit Gateway all routes in its segment. So very important, you don't have to configure static routing there. And site-to-site VPN. This is something that you folks are probably very familiar with, and Transit Gateway also supports it. Now, a very big ask from our customers has been support for native direct connect connectivity on Cloud WAN. And we have launched that with the Direct Connect Gateway attachments. So now you can directly attach a Direct Connect Gateway to your Cloud WAN core network segments. And when you attach the Direct Connect Gateway, you do need to specify which regions you are attaching that Direct Connect Gateway to. Remember that the Direct Connect Gateway is a global construct, right? So when you attach it to Cloud WAN is across a set of regions that you define in the core network policy. So you do need to make sure you specify which of those core network edges need to learn the routes automatically from Direct Connect Gateway. Very important, the best practice here is unless you have bespoke routing scenarios, attach the Direct Connect gateway or associate the Direct Connect gateway attachment to all core network edges so that routing happens directly between the core network and Direct Connect gateway without creating cross-region dependencies unnecessarily. Another very important piece is that you can connect multiple Direct Connect gateways to your Cloud WAN core network. And we have here customers who choose to do end-to-end network segmentation, so keep the segmentation in Cloud WAN all the way through their hybrid environment. Or we have customers who also choose to bring Direct Connect into a sort of a hybrid segment and configure inspection between. And because we're talking about inspection, really, really important, Cloud WAN comes in to simplify how you customers do centralized inspection, either centralized egress inspection or cross-segment inspection. Let's look at service insertion. This is a feature that we've launched this year at Reinforce, and it was really, really weighted by all customers. To power service insertion, we have a new component, the network function group, and let's see how you can configure it. So let's start with egress inspection. We have our Cloud WAN core network. Let's say it's deployed across 3 regions. You have to have a VPC that contains your network functions, right? Your network functions don't necessarily need to be in the VPC. They could be attached, for example, to Transit Gateway, or they could be in your on-premises environment. However, for this example, we consider it being attached directly to Cloud WAN in a VPC. So step 1, creating a network function group. Again, it's a policy definition, right? The network function group gets created. It is a global construct across the regions where you create your core network, and consumes 1 segment in your core network. Now, step 2, the attachment policy for the network function group. Really important. So that VPC attachments or route table attachments, when they get created, they get associated with the right segment. Then we create the attachments from VPCs. Those attachments are automatically mapped to the network function group. And step 4 here is probably my favorite step. And it is my favorite step because it means documenting your intent. And it is a reference of what you are planning to do with your inspection architectures. Which segment requires centralized egress, right? This table is something that I ask all my customers to do, to have it in a wiki page or in a documentation page. Now, once you've documented this, you can translate it into the Cloud WAN core network policy, and you can configure segment actions. Now, these segment actions, you can configure them on a per segment basis for all the segments that require that inspection intent. And they translate into routes that are injected into your route tables in Cloud WAN. Now, there's the send to action. It is specific to centralized egress, and once you configure it, these routes are propagated into your route tables. Now, very important, you can override your centralized egress. If you have regions where you don't have that inspection VPC, you can override that with the edge overrides. Now, for cross-segment service insertion or inspection, we start with the same baseline architecture, 2 regions, inspection attachments in each of those. We still need to document our intent, and once we document it, we translate it into the network policy with a segment action that this time is a send via segment action, and that makes sure to propagate the right routes in the route tables to maintain segment or routing symmetry for traffic. You folks know that when traffic traverses a firewall, both egress and return traffic, or outbound and inbound traffic, need to traverse the same firewall so that the firewall knows that session. Send via action helps you maintain that, and it has 2 modes for configuration, single hop and dual hop. Now, we've talked about all layer 3 connectivity, right? We've talked about transit gateway, VPC peering, and cloud. And if we go towards, again, that evolution of networking and connectivity on AWS, we get into the realm of application networking. This is something that, it's a term that we've coined a couple of years ago. And we've gathered under application networking a few services on AWS that were existing and a few ones that are new. So let's start with elastic load balancing. We're not going to dive deeper into architectures using elastic load balancing. There are 3 types of load balancers: application networking gateway load balancer on AWS. And application load balancer had a very, very fruitful year. A few features that were really requested are up there, such as header manipulation or header modification. Network load balancer also had a very full year. A lot of features related to the high availability and zonal failover were included, as well as configurable TCP timeout. Now, API Gateway, again, had a very big year, and my favorite launch here is the support for private custom domains together with IPv6. Very important. Now, 2 very foundational services of application networking, AWS Private Link. Matt talked a bit about in the introduction of how you can use AWS Private Link. It does give you access to AWS managed services or third-party services on AWS that you deploy and manage. We have over 190 AWS service endpoints that integrate with Private Link, and a lot of SaaS providers that are natively integrated. Now, if you look at foundations, 2 types of services that you can access through Private Link. AWS services, which allows you to configure either gateway endpoints, so for Amazon S3 and for DynamoDB. These gateway endpoints do not use IP addresses from your VPC subnets, but so they do require your route tables to be updated, and interface endpoints that allow you to communicate to AWS managed services as well as your custom managed services by using elastic network interfaces in your VPC. Now, for custom managed services, the same principle applies for VPC interface endpoints. When you create them, you do need to first create the service side, which is a network load balancer, and an endpoint service that powers the interface endpoint on the consumer side. Now, very important from considerations perspective, the cross-account connectivity is there. IPv4 and IPv6 for your custom managed services is supported. And you can have overlapping IP addresses. From DNS perspective, a lot of times you folks ask, well, how is DNS managed for Private Link? AWS managed services have, in their majority, private DNS managed. For your custom managed services, either the service provider can manage DNS, or you can manage DNS on the VPC using private hosted zones. Now, really exciting launch. UDP support for AWS Private Link has been around for a long time as an ask. And we are now supporting it. Important part here is you can connect to Private Link services over IPv6 and IPv4 from the consumer side. However, the target group must be IPv6. Very important. The question is not if the targets can be dual stack. They can absolutely have dual stack capabilities. However, they do need to be registered in the target group using IPv6. And last but not least, it was a couple of days ago, or actually Sunday launch, VPC resources. Customers have asked us to allow them to expose through the Private Link model services that do not require load balancing. right? That don't need to be front-ended by a network load balancer, or cannot be. And resources come with a couple of new constructs. Resource gateway, it is the construct in the VPC that allows you to connect to the resources. The resource configuration is where you define your resources, either by ARN, IP, or DNS, very important. Those resources, if the VPC where the resource gateway has access or is deployed, has layer 3 access to them, they can live on premises as well, or in other VPCs. And last but not least, the endpoint side, which is the client-side communication. With VPC endpoints, you can have one endpoint per resource configuration, and you can access these resources in remote VPCs and accounts. Now, from considerations perspective, keep in mind that the resource gateway can have multiple resource configurations associated to it, and you can configure those resource configurations to be on premises, right? Now, cross-region private link. I think probably a lot of you folks in this room have thought about cross-region private link at least once using private link and cross-region support. It is here. You can now access private link powered custom services through cross-region VPC endpoints. The only thing you need to do is, for existing and new services that you manage on the endpoint service, to enable the regions where you want that service to be consumed. You don't need to redeploy the service. You don't need to redeploy the network load balancer. You don't need to recreate endpoints, right? Everything is there all together. Very important, it is supported today for custom managed services, not for AWS managed services. And our last service, and the one that I am personally most excited about, Amazon VPC Lattice in the application networking space. With VPC Lattice, you can simplify and scale and secure connectivity on AWS. It is integrated now with all AWS compute options, including ECS and ECS Fargate. We're going to talk about that as well, and gives you unified traffic controls. VPC Lattice components are these four. Really straightforward. Let's go through each and every one of them. So in VPC Lattice, we have a service. The service has listeners, routing rules, targets, and target groups. So we wish Lattice would have done our slides, but no. It is just a way of us showing some fun service names here. The second one is the service directory. Whenever you create a service in an account or a service is shared with you through Resource Access Manager, it appears in the service directory. Then we have the service network, which is a logical construct that allows you to bring services and clients together that have the same security and connectivity requirements. Both the services and the service networks are RAM shareable constructs. Depending on your operational model, you can choose which one you want to share. And you can associate services to the service networks. Auth policies can be configured on either the service network, the service, or both, depending on the level of granularity in your operational model again. And they are actually IAM policies. So something that customers are familiar with from interacting with AWS managed services. From access perspective, you can access a service network through a service network association from the client side, onto which you can configure security groups. Routing is automatically handled by VPC Lattice. Routes are automatically populated in your route table. From DNS perspective, the same model that AWS Private Link has, where you would update your private hosted zones with your custom names, is supported for VPC Lattice as well. And you can simplify that using Route 53 profiles, which is the new launch for this year too. Now, I mentioned ECS and ECS Fargate that are also supported and have been a recent launched, both of them for this. And you can have services in ECS or ECS Fargate that are automatically integrated with your Lattice service network. No need for load balancer anymore, for application load balancer, which was the old way of supporting these services. Another very big feature ask was TLS pass-through or TLS listeners, with which you can have services that communicate to each other using MTLS. Very, very common use case for customers who implement end-to-end encryption. So with TLS listeners, VPC Lattice is only a transport and allows you to consume, or allows clients in the VPC to consume services directly. And last but not least, again, today launch VPC resources supported in VPC Lattice. Same as for private link, customers have asked us to allow them to associate with VPC Lattice their non-load balanceable resources. So same constructs that you know already: resource gateway, resource configurations, ARN-based, IP-based, or DNS-based. You can associate them with the service network. Now, from here, if we recap all the service types you can bring into a service network, you can consume all of them. Last but not least, the last feature that we're going to talk about in VPC Lattice is service network associations. Now, with service network associations, this is the default way of consuming service network endpoints. Sorry, the service network associations are the default way of consuming a service network. IP addresses for IP destinations are not from the VPC. And very important here, they act very similar as a gateway endpoint. Now, with service network endpoints, very, very similar to private link interface endpoints, you can consume a service network, or you can access services in the service network using endpoints in your VPC. They work very, very similar to a private link endpoint. You create them, they consume IP addresses from your VPC, and they allow you to also have multiple service networks that you can access from your VPC. So a very big ask from our customers. You can access service network endpoints from on-premises, and very, very important, because they use IP addresses from your VPC, you can access them from other regions as well. So if we look at cross-region communication with VPC Lattice, we've chosen to highlight two options. One, where you use your layer 3 connectivity mechanisms that you already have deployed in your environment. And the latter is where you make full use of these two new features, VPC service network endpoints, service network VPC endpoints, and cross-region support for private link, where you can make this end-to-end communication between the clients and the service in a different region using the native constructs. Now, this was application networking. Let's go to Zero Trust.
All right. Wow, connectivity, huh? There's a lot there. You can see we've really focused over the last couple of years on connecting VPCs together. I really love VPC Lattice. I mean, that's one of our newest services which are just making it easier to get applications or users connected to applications. All right, let's talk about Zero Trust, or verified access, or as we actually call it, AVA internally. I think it's not our public name, but yeah, you guys can call it that too. That's fine. All right, so AWS verified access. So basically the idea here was when you start with a VPC, it's really a walled garden. And so when you give access to that walled garden, you're saying, hey, you're allowed to connect to anything, or you're allowed to connect through into the walled garden and anything inside that walled garden, security groups and NACLs aside. With verified access, what we wanted was the ability to set policy control around access to entities inside the VPC itself. And so traditionally, verified access would support HTTP and HTTPS endpoints, and you could use AVA to connect to those endpoints. And it basically looks like this. So we've got our subnets on the right-hand side. We've got an ALB or NLB with our target groups, which are basically our application. that would be called an access group for verified access. Verified access is a front-end or public-facing service which you would reach out to access your internal VPC services, but then you would also go through integrations with your things like device posture and integrations with your SIEM policy control and security partners. We also have AWS WAF there as well. And so users would basically come in from the public internet, go through their security policy checks through AVA, and then be able to access the application, HTTP and HTTPS applications. Now, as of I think I got this one right. Yesterday, yes. Yesterday, we have a preview for non-HTTPS applications. And so the idea here is basically you can use AVA to access applications that aren't front-ended or using the HTTP protocol. So let's dive in and have a look at what that looks like. Now, the reason why we wanted to do this was for folks that wanted to use AVA for access to things like ephemeral things. When you wanted to SSH into a host within a VPC, you could use a Bastion host, and folks have been using Bastion hosts for many years, but AVA can actually be used to connect to a Bastion host or an ephemeral entity like a Bastion host inside a CIDR range, inside a VPC. And so it basically looks like this, where we've got an Amazon VPC, we've got a TCP endpoint, for example. This could be maybe RDS or something similar. Or we have a CIDR range that we assign within the VPC, and when we add services inside that CIDR range, like a SSH endpoint, we'll automatically detect that and add it as an AVA endpoint. And so what you can basically do now is use AVA to connect through to those services. So it used to be just HTTPS, but now TCP and ephemeral services as well through the public internet too. Very cool stuff. Some considerations here. So really the whole idea here was to give VPN-less access to things inside your VPC. And I think AVA has really given that capability. Okay. So let's move on now to Edge. Now we could do a whole session on Edge and CloudFront, and those folks have been super busy. We've got a few different things that the CloudFront team have been working on this year. And so we've just got a list here because we don't have that much time to really dig into everything. But private VPC origins. This is something that I've heard from customers for a long time in that, hey, when I'm using CloudFront, I've got a public endpoint as an origin, and folks can reach out to that origin and try and bypass my CDN. Now, if you're using S3 or something similar, you can lock down that endpoint. But now, with private origins, you can actually have an endpoint inside a VPC that's not publicly reachable and have CloudFront reach out to that. Coupled with, we now support Anycast IPs for CloudFront. So similar to Global Accelerator, where you'd get an Anycast static IP, with CloudFront you can do that as well. Embedded POPs. I think we have now around 1,700 CloudFront POPs, which is including around, I think it's around 600 embedded POPs. And what an embedded POP is where we've taken a traditional CloudFront POP, we've made it a little bit smaller, and we've packed it right into the last mile of a service provider's network. So we're getting as close as possible to the end user. So we've been able to deploy embedded POPs far faster than traditional POPs and get them far closer to users as well. We also support gRPC, so if your API endpoints are using gRPC, you can now use CloudFront as well. Now we get into a topic that I've been coming up against in AWS, talking to customers, and I know you have as well, Alex, observability. So basically, getting visibility or observability on the things that are running inside a VPC, right, and the traffic running inside a VPC. So we've been doing a lot in this space recently. And one of the things we've noticed customers are doing for instance-based monitoring, using an EC2 instance and using a tool that we've developed with our ENI adapter called ETHtool. And so what ETHtool basically does is it will give you details into the resource limits that are being breached on an EC2 instance interface. And so what you're seeing here is there are limits or resources that apply to an EC2 instance, for example, PPS or packets per second throughput limits. ETHtool basically gives you the ability to say, hey, show me whether I'm breaching the PPS limits on this instance. And so what folks are then doing is, I've got a quick console output here for ETHtool. You'll notice here I've got a whole bunch of contract allowance available. I'm not using any of my PPS. I didn't spin up anything on this instance. I just said, hey, just show me what the output is for ETHtool. But this is what you can expect. But folks are basically taking the output from ethtool, pushing it through with a Prometheus agent or something similar, and then forwarding that onto Grafana. So they're getting instance level stats in their dashboard, so they're trying to build this single pane of glass, and ethtool is really helping there. And we're looking into what we can do with ethtool in the future. Now, we also have infrastructure performance. One of the pieces of feedback we got was, hey, the infrastructure that you folks run, we need to run agents on top of that to figure out what the latency is between availability zones. In truth, availability zones aren't all equal distances from each other, so it's probably something like this. And if you've got an application that's traversing multiple AZs, you may see increased latency. So you may want to know, where should I deploy this application? And so what infrastructure performance does is it's down here under Network Manager. And if we go on the left-hand side here, infrastructure performance, you can see all of our availability zones and our regions and what the latency looks like. So I'll do a really quick kind of view here. And you can see down on the bottom, we've got a history of what the latency actually looks like there. So super useful. You don't need to spin up instances to try and figure out what these latencies look like. Very useful tool. It's been around for a little while, but I noticed folks actually haven't been using it that I've been talking to. So definitely worth mentioning here. We also have CloudWatch Internet Monitor. We've got that was released, I think, about a year ago, but we've got a few new features here. So we've got an internet outage map, cross-account support, and we also have one-click integration for network load balancer and ALB. Now, just to give you a really quick preview of what that would look like, it's on the left-hand side here under CloudWatch. There's a new service there which we'll talk about in a second if we have time. We are almost out of time. But basically, you can see the internet outages that are happening, or internet weather map here, and you can configure a monitor to say, hey, I'm in this particular location, I'm interested in these particular events that are happening in my region. Now, if we move on here to Network Monitor, this was released in around January this year, where for hybrid networks, what we're doing is we're basically saying you can configure a monitor through CloudWatch Network Monitor and have a target endpoint. And what we will do is configure a set of probes here on the left-hand side. You'll notice the little P icons there, and we'll monitor target endpoints in a hybrid destination. And so you can get feedback on what the traffic looks like over potentially a direct connect. Here we've got a redundant set of direct connects. Some considerations there. That slide will be available in our takeaways. I want to get through to the closing here because we are coming up on time. Lastly, this one released yesterday.
Just today. Today or yesterday. Yeah.
Today or yesterday. It was super, super recent. So CloudWatch Flow Monitor. This has been a really good one that I've been looking forward to. So what we do now is we package up an agent, or the Flow Monitor agent, onto Amazon Linux, or you can deploy it as a binary, and we'll take those traffic statistics. We'll actually look at traffic that is traversing this agent, think eBPF style technology, and we'll export that to Amazon CloudWatch. And so you can get a whole bunch of detail on the network health of the paths that are taken for traffic going over your EC2 instances. Now, it's not just between, say, EC2 instances in a VPC, it's also across things like, a transit gateway. So we can report on network health of entities that are actually running inside a transit gateway and say, hey, there's actually some problems with the transit gateway service, and you're experiencing that through Network Flow Monitor. So I'd definitely implore you to look or check that one out. Okay, Alex,
Let's
do you want to
close
close it out
here.
here?
Let's close it out. It's been a lot, folks. This is where we started in December 2023. Now, all the way through 2024, we did a bunch of things. We launched a bunch of features that you folks have asked for. We started with IPAM, IPv6, a lot of connectivity over IPv6 available now with EC2 Instance Connect. Security group VPC associations, block public access, transit gateway security group referencing, Cloud WAN direct connect support, service insertion, application load balancer, network load balancer, and API gateway features. VPC resources for private link, UDP support, cross-region support as well. For VPC lattice, ECS Fargate integration, TLS listeners, service network endpoints, and VPC resources support. a lot of things, right? It's been a whirlwind. We have gone in almost 60 minutes over all of these features for all the chapters in connectivity that we have, and we ended with observability. So here's where we are in December 2024. Super excited, looking forward to December 2025. Thank you so much. And I know that you guys love to take photos. You have asked us a lot for the architectures in this session. So Matt had the amazing idea for us to have this QR code and a condensed, abridged version of the slides that you can take away and use them wisely. So thank you so much, folks, for joining us today. Thank you for sticking around at the end of the day, and have an amazing re:Invent, and see you next year.
Thanks, everyone.